Welcome back to the hyperbolic coding chamber. This is day 83. We are back once again. Yesterday we were doing some easies. We just did one problem and then we did the follow-up, but we didn't read the solution. So we're going to start with reading the solution today. But yeah, before then, we're going to look at some comments. Had a legendary, absolutely legendary comment from Thomas Wong. He said, I did university in Australia at UQ. I did a course taught in Java as my first coding course. We wrote a game similar to Minecraft. We were taught inheritance, OOP, polymorphism, and some graph traversal algorithms for this course. I thought I was going to fail since I didn't know a single line of code at the time, but I survived. Sometimes throwing a guy who didn't know how to swim in the ocean could drown them, but if they survive, the reward is huge. That's also my logic for LeetCode. If you can tough out those mediums and hards, you don't need to do easy questions. But the pain during the process was very much suffering. I guess no pain, no gains. Yo, I read this morning when I woke up, and it's pretty much a story. Thomas is a storyteller. You are a storyteller, brother. That was incredible. And what he's saying is all facts, right? I think if you look at every pretty much performance marker of humans, if you're looking for intelligence, capacity, right, bandwidth for physical exercise, heart throughput, right, how much blood you can shove through your body, right, pretty much look at all these things, muscle building, endurance, right, almost all of these things you enhance by pretty much putting yourself at the peak of your ability. And typically being at the peak of your ability involves significant struggle or frustration, which typically means suffering. And that's, just how it is, right? It's just how it is when you're trying to get better at something. But yeah, I read this and I thought it was just an incredible way to sum up pretty much the grind of getting better at something, which is true. There are some people I'm certain who took that class or who have been thrown into the pool to swim, right, when they can't swim, and they do come out with the ability to swim. The reward is huge there at almost like a tenth of the time, but it really comes down to ability to tolerate suffering. And yeah, that is a tough one. That is indeed a tough one. But I think we'll definitely get to mediums. I just think we're at a point now with the grind where I think I would like to pretty much do all the LeetCode problems, and then who knows where we'll go from there. But I think we're at a point where I think I just want to do like a recovery run with some easies, because constantly being exposed to the old problems that I'm doing, as well as like new mediums, and we haven't done any new mediums in a while, it's just been a lot, especially with some other things I'm doing off recording, like just learning other things. So that's been very much tough. So I'm thinking, since we have time, we'll just do the easy route. But maybe we don't want to spend too much time on each problem, but we want to spend enough time so that we're learning. But yeah, I think there's always some aspect to getting better at something or trying to increase performance in something. Like even when you're sprinting or you're a runner, right? They even have recovery runs where you run maybe the same distance, but not as hard, or you run a shorter distance, but maybe at your regular pace. So I think what we're doing right now is like a recovery run, where we still practice every day, but the intensity of the practice is just a little bit less. So some days you have to walk so you can run. So I guess that's what this would be, to be honest. But I thought this was a legendary story, so much so that I thought about copy and pasting it into the Discord. But legendary human, legendary grinder. Yeah, I really appreciated that comment. That was just a dope comment in general. But yeah, that's kind of all we have for today. So I think I'm just going to jump into the easies. I'm going to start with just reading the solution from the last one because I just didn't have any brain power left to read it. And then we'll do the next easy, which looks to be search insert position and length of last word, and add binary. Maybe we'll just start speed running these problems. The faster we get through all the easies, right, faster we get to the other problems. So let's just do that. So we're going to jump into it. Make sure to join the Hyperbolic Coding Chamber. It is a Discord that is rapidly growing. And today, for a limited time, if you click the join button in the Discord below, you'll be able to join with no wait time. There's usually a long entry list or a long queue to enter the Discord. So you're going to want to join while you have the chance. So we're just going to jump into it. So the problem was palindrome number. We did two versions, one with conversion to a string and one with a stack. that we reversed. But I wouldn't really say it was even a stack, to be honest. It was just an array that we created. So let's see, revert half of the number. First, there's a couple of different solutions. Oh, there's only one here. Revert half of the number. First idea that comes to mind is to convert the number into a string and check if the string is a palindrome. But this would require extra non-constant space for creating the string, which is not allowed by the problem description. I think this is why this one has some downvotes, because that doesn't mention that you can't use non-constant space. Second idea would be reverting the number itself, then compare the number with the original number. They are the same, then the number is a palindrome. However, the reverse number is larger than int max. Overlook issue of the reverted number. I think they did the same thing that we did, except they stopped at half the number, which is interesting, but that is pretty cool. So we'll just go to the next one, which is search insert position. Given a sorted array of distinct integers and the target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. Interesting. You must write an algorithm with log of n runtime complexity. So it's like basically a binary search, but for the insert position. So we're given a sorted array of distinct integers and a target value. Return the index if the target is found. If not, return the index where it would be if it were inserted in order. This gives me binary search vibes. Well, if we do a binary search, right, we'll know whether or not we can find the number 5, right, because we'll eventually find the target. But if we can't find the number, the index for which we stop the binary search should be the index they're searching for. For example, if we take our left, which is going to start at 0, right, and I'm not actually going to write it yet, but our right, which is going to be, let's just say in the case of example 2, right, which is going to be the length of the array minus 1, should be 3. We'll calculate our pivot, which will be left, right, plus right minus left, which is 3 minus 0 over 2, which is going to be 1.5. Floor is 1. Right, so we're now going to be at index 1, which is going to be 3. We're going to say, okay, is target equal to this index? No. Is target less than the index? Yes. Since it's less than the index, we're going to move our left, right, to our new pivot, or our midpoint plus 1, and our midpoint was 1. So we'd make it 0, 1, 2, right? And then we'd have 2 and 3, right? And now we do 2 plus 3 minus 2 is 1 over 2 is 0.5, floor is 0. So 2 plus 0, I'm going to say, okay, is 5 less than, does 2 equal 5? No. Is 2 less than 5? Yes. So now we're going to say our right, is now going to be equal to pivot minus 1, which is now going to actually give us 1, right? And the index for which we actually should have inserted it looks like it should have been left minus 1. So let's see if it works for this one. So now, right now I'm thinking what we return is actually going to be left minus 1. But let's see if this makes sense for this one right here. Left is going to be equal to 0. Right, it's going to be equal to 3. Right, we're going to get 1 here. Right, 3 is less than target, so left is going to become mid, which is 1 plus 1, which is going to be, oh no, it's going to be, yeah, 1 plus, which is 2. Yeah, I'm not writing it, but this is pretty much the logic for a binary search. I'm just going through it in my head, basically. But so we have 2 and 3, right? The next value we're going to check, since we just did it up here, is actually going to be 0, 1, 2, right? We'll do 3 minus 2 is going to be 1, divided by 2 is 0.5, floor to 0. 2 plus 0 is going to give us 5, right? 5, still less than 7, so our left is going to be equal to 2 plus 1, which is, or mid plus 1, which is actually going to be 3. So now we're going to be here 3 and 3, right? 3 plus 3 minus 3 is 0 over 2 is still 0. Now we're going to check if this is the value. It's not, and so we would actually have, right, 6 is still less than target, right? And so we would say this is now going to be equal to midpoint plus 1, which is going to be 4. So it looks like there could be 3 cases here where if left is equal to the length of the array, it's just going to be inserted at the end. Otherwise, if left is less than the end of the array, then we should just insert 0. Otherwise, we should just return the index. I think that's the case. We could just write it and then just fumble our way to the solution, but I want to actually think it through first. Maybe to start, it might make sense just to write it out just so we can make sense of the logic. But left minus 1. Right. We'll say left greater than nums.length. We return left. Left minus 1. Otherwise. And then maybe these could be our 3 cases, but let's just write the binary search for now. Let's see if our input can be empty. Nums will not be empty. Actually, we could just test all this with an array integer of size 0. Array of size 0. I never think about that. Let's just say our target is 0, right? Our left is going to be equal to 0, right? And our right is going to be equal to length minus 1, which is also 0. Let's say our target is 2. 2 doesn't exist, right? So now we're going to calculate our midpoint. It's just going to be left, which is 0, plus right minus left, 0. It's just all going to be 0. We're going to get 0. Now 0 is less than 2, so we're going to return. We're going to add 1 to left. Since we added 1 to left, we're going to be done, right? Because we only run this while left is less than right. And based on our logic, right, if left is greater than, let's say if left is greater than or equal to nums.length, then we should return left. So that does work for that one. Let's just say if we're looking for -1. Left would be 0, right? And so our midpoint would be 0, right? 0 would be greater than -1, which would mean that right would now equal 0 plus 1. Now left is equal to 0 if left is less than you could say if left equals 0, then return 0. Otherwise, we could have something like 0 and 2, 1 insert 1, right? We check our first one, 0, right, is less than 1, so we change left to be 1, right, and right would still be 1. The next thing we check would be 2. 2 is greater than 1. So we'd actually do it like, we'd actually turn 1 to 0 and it would stop. It looks like we would just return left. I think this makes sense. So let's try, we'll say left is equal to 0 to start. Whenever we do a binary search, right is going to be equal to the last index in the array minus 1. We always run while left is less than right. And the first thing we do is always calculate our midpoint, our pivot, which is always left plus right minus left over 2 dot floor. And we say if nums sub pivot equals target, right, then what do they say we should return? Return the index, right? So we would return pivot. Else if nums sub pivot is less than target, left is equal to pivot plus 1. Then we duplicate this, and if it's greater than target, it equals to pivot minus 1, except we're going to use right instead. Then down here is where we have all our logic. Then we can compress both of these into left equals 0, return 0, otherwise return left. So we'll say return 0 if, otherwise return left. First for the first case, because it's just a regular binary search, let's just change our target to 2. Okay. Let's just say we change our target to 7. Looks like our answer is 1 off. But this is what I wanted to avoid. So now we're just going to fix the problem, but it's just because we clicked run. And we can't always click run. I wanted to actually know why I'm adding 1 to the number. Okay, so maybe it's not that simple. One. Should only have 3 cases. Turn 0 if left equals 0. Obviously, I think lines 21 and 22 are wrong, but I think we were going through the binary search in our head, maybe with just faulty information. Well, let's just say that we have 1, 3, 5, and 6. We have 1, 2, and 3, and we'll change our input. Right, and let's say our target is -1. So it does work for that. And let's just say now our target is 4. With this one, we seem to still be working. Now, as soon as we try to get something in between, like 1.5, let's just change this to 1, 2, 4 so you can actually have an insertion point that makes sense. We'll say our target is 6. Our alpha was 3, they expected 2. If I'm correct, we should still have the same problem if we do 2. So I think what we need to do is we have return left plus 1. think what we need to do is if the number, the last number, we can't really know whether or not it should have been the last number in the array or before the last number. So I think we're supposed to check. So what if we said return left if we just said if num sub left which is either 0 or the last element in the array, if num sub left, this is what we can do. We can say return num sub left is less than target. Num sub left is less than target, then we should return left. Right? If num sub left is 1 and it's less than 2, index where we would insert it would actually, so if num sub left is 1, which means the first element in the array is 1, 5, and 7, right? And let's just say our target is -1. If num sub left, which is 0, is 1 less than -1, no. Let's just say it was. If 1 is less than 2, then we'd like to return left plus 1. Otherwise, we'd return left. So if this was -1, num sub left is 1 less than -1, no, which means what we should return should be left, which would be 0. Need to remove this line. With inserting there. Now what if we insert past it at 6? Now what if we insert at the end at 9? And then at the front at -1. Yeah, that was unfortunate. I really wanted that to be done faster, but that was cool, I guess. Interesting. It seems like in their version, it's the less than or equal part that seemed to have messed us up. So if you do, I guess, an equal then you can just return left. Interesting. 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 Let's try length of last word. Given a string S consisting of words and spaces, return the length of the last word in the string. This word is a maximal substring consisting of non-space characters only. The last word is world with length 5. Luffy is still Joy Boy. Last word is Joy Boy. S consists of only English letters and spaces. There will be at least one word in S. So I think you could do this with split and then return the last element. I think you could do it faster. Iteration. So let's try that. So I think the point with these problems are not really just, they don't want us to just use built-in functions. So if we took the string, we iterated in reverse, we need to find the first, we need to make sure left is a non-space character. And then as soon as we do that, then we can go ahead and find the next space character. So iterate in reverse, find first non-space char. And then from first non-space char, find next space char. And then I think we could just do that. So I necessarily think we need to iterate from the end completely. So what we could just do is start from s.length minus 1, and then go up to including 0. Or we could just do is just say right is equal to s.length minus 1. And then this will run while right equals space. And then we're going to do end. And then we do right minus equal 1. Right, so we'll say right is greater than or equal to 0, right, and right equals space. We're going to do minus 1 until it equals n, which would be perfect. And then here we can have the word, which is going to be an empty string. And then from here we'll say while right is greater than or equal to 0 and right does not equal space, we're just going to do word I think you can do something like s sub right. You can concatenate or something like that in Ruby. Word sub right will concatenate the character. And we'll do right minus equal 1. And so as soon as right equals a space, we're going to stop. And then we can return word. So let's see if this makes sense. Right is going to equal to s.length minus 1, which is going to be d. Right, while right is greater than or equal to 0, which it is, and right equals space. Well, it doesn't equal space, so we're already actually at a character we can use. Now we're going to start at d and say while right does not equal a space character, we're going to add d to the word. Right, D, L, R, O, W, and then it's going to be space. We're going to want to stop, and then it looks like we're actually going to have to make this an array, and we'll just do push s sub right, and then what we can do is just do word.reverse.join. I don't even know if you can do join. And I think this would get us word. Oh, we're just looking for the length. The length of the last word, so we actually don't even have to keep track of word. So we'll just say start is equal to right then, and start is greater than or equal to 0. Or we can just do length, len is equal to 0. Right, we start at D, right is greater than or equal to 0, right doesn't equal space, 1, 2, 3, 4, 5, and so we should just be able to return 1. output is 11. Oh, right does not equal space. It should be S sub right does not equal space. That's my bad. So this works, and I think this would take less time than using split and taking the last character, but we'll take it. And yeah, let me look at the solution. String index manipulation. So this is exactly what they do. This would be O of n, where n is the length of the input string. That is true. That would be the worst case, because if there's no space, there'll be at least one word, but no space. So worst case would be n linear time. Constant space, one loop iteration. We will take it. That is a wrap for 83.